All right, in Concept D, we're going to continue on talking about periodic trends. You'll be able to relate different periodic trends to an atom's atomic structure, continuing on what we did with our atomic radius. We're also going to be able to determine and explain changes in our electronegativity values and ionization energy and how that influences various atoms. So a quick little review of atomic radii trend. As you go down a group, the atomic radii increases. And why does this happen? There's an additional shielding between the nucleus and the valence electrons, and these additional energy levels are then farther away because of that. As we go across a period, the atomic radii is going to decrease. It gets smaller as you move towards your nonmetals. Why does this happen? The electrons are added to the same energy level, and while the effective nuclear charge and attraction stays the same, these additional electrons are going to repel each other and push each other away from the nucleus to get more space from each other. So how does this all relate to our two new trends? Electronegativity is an atom's attraction for electrons in a chemical bond. The higher the electronegativity value, the more the atom attracts the electrons to it. So fluorine has our highest electronegativity value of 4.0. That means fluorine has the best attraction for electrons in a chemical bond. One way to look at this is kind of like the Grinch, the greediness of an atom or ion for electrons. Again, the higher this value is, the better it attracts electrons, the more greedier it is. In general, the closer the electrons are to the nucleus, the more attraction there is, so thus there's a higher electronegativity. And I'll come back to that in just a second. So as we go across the period, the electronegativity values are going to increase. The reasons for this is that there's a greater effective nuclear charge and shielding does not increase. Basically, if a nucleus can attract its own electrons stronger, which then results in a smaller radius, it can then attract the electrons in a bond better. So the smaller atoms, which are pulling in their electrons better, are then able to attract electrons in a bond better. As you go down a group, the electronegativity values are going to decrease, and this is because of shielding. If the nucleus can't attract its own electrons well, because of all of those kernel electrons interfering, then it's not going to be able to attract the electrons in a bond well. Alright, so we're going to now move on to first ionization energy. So this is the energy required to remove the most loosely held valence electron in order for an atom to form a positive ion. This is kind of like Scrooge, where atoms are being stingy with their electrons. The lower the amount of ionization energy, the more easily the electron is lost. So if you look here, in order to lose that electron, an atom has to absorb a certain amount of energy to become that positive ion and lose the electron. So the lower that amount of energy is that it has to absorb, the more easily we can remove that electron or that electron being lost. So first ionization energy is directly proportional to electronegativity. The more tightly an atom attracts electrons, thus the higher electronegativity, the more energy it's going to take to require to remove that electron, and thus the higher ionization energy. So as electronegativity increases, ionization energy increases as well. So what are the two big trends? As we go across the period, the ionization energy is going to increase. We have an increased nuclear charge and shielding does not increase. So the stronger the attraction between the nucleus and the valence electrons, the more energy is going to take to remove the electron. That is why as you move across towards the nonmetals, those tend to not ever lose electrons. And that's because it takes too much energy to remove them. As you go down a group, the ionization energy trend is that it's going to decrease, and this is because of that increased shielding. There's a weaker attraction as you go down a group between the nucleus and the valence electrons. Thus, because of the weaker attraction, the less energy it takes to remove the electron. So elements at the bottom and left have the greatest tendency to lose electrons because of their low ionization energies with very little energy it takes to remove. And we'll see that the elements in the upper right, besides the noble gases, are those that have the greatest tendency to gain electrons because of their high electronegativity and ionization energies. So one last trend I want to discuss is reactivity. This is the ability or tendency of an element to go through a chemical change, so basically to react with another element. So metals are the losers of the periodic table, but don't worry, metal losers are positive because they lose electrons. Okay, so as you go across a period, the reactivity of our metals decreases. That's why group 1 metals are the most reactive, and yet our transition metals are the least reactive. So the reasons for this is the same as all of our other trends. We have an increased nuclear charge as we go across a period, and shielding does not increase. So metals are able to lose more easily. Now, metals, as we go down a group, their reactivity is going to increase, and this is because of increased shielding. It takes less energy to remove those electrons that they're going to lose, so they're going to be more reactive. Now, while metals are losers, nonmetals are the bullies when it comes to electrons, but remember, bullies are negative. So these bullies, when we go across a period, the reactivity is going to increase, except for the noble gases in group 18. As we go across, it's able to gain electrons more easily because of an increased nuclear charge, and that shielding does not increase. So they're able to gain electrons more easily. As you go down a group, the reactivity of nonmetals is going to decrease, and this has to do with increased shielding. As you go down a group and the atom gets bigger, they're going to have a weaker ability to attract electrons in a bond. So nonmetals just can't gain electrons as well as you go down a group. So our most reactive metals are in the bottom left. So as you go down a group and as you go to the left, you have the most reactive metals. And then the opposite is true for the most reactive nonmetals, going towards fluorine. So as you go to the right of a period and up a group, you get your more reactive nonmetals. So here we're just going to kind of combine a couple of our concepts together. Metals have a larger atomic radius, and they have a lower ionization energy and electronegativity. Because of these properties, electrons like to lose electrons and form ions with a positive charge. We're going to see that our metalloids are basically in the middle of our metals and nonmetals. They have a medium radius electronegativity and ionization energy. They tend to share electrons in their bonds, and then their ion charge could be either. Now, nonmetals tend to be our smallest elements, and they have the highest ionization energies and electronegativities. Now, what usually happens depends on what they're bonding with. Nonmetals will gain electrons if they're forming with ionic bonds, or if they're bonding with other nonmetals, they'll share to make covalent bonds. And in either case, for the most part, we'll see that our ions that form from nonmetals, which come from our ionic bonds, where they gain electrons, are going to be negative. Alright, so take a second and pause your video. You're going to be kind of jotting down a couple of things in the notes momentarily. I have some different trends for you to think about and copy down into your note packet. This is basically, as you can see, as we go down a group, atomic radius increases, and because of a larger atom, we have a decreasing electronegativity and decreasing ionization energy. The opposite is true as we go from left to right. The atomic radii is going to decrease, we get a smaller atom, and because of that, our electronegativity and first ionization energy increase as well. If we look at our nonmetallic character, our reactivity of our nonmetals is going to increase as they go to the upper right, and then our metallic character, or our reactivity of metals, is going to increase as we go to the bottom left. So take a minute, jot these things down. I'm going to be checking this section in your notes to make sure it's complete. Okay, so that is it for our periodic table. We'll spend a lot of time tomorrow going over these two trends because they're going to stay with us for a good part of the year and influence some of the other topics we're going to talk about.